Hello, my name is Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third party value evaluations, we provide training and certification, we provide equipment re rating.
Welcome back, folks. This is episode 2 of part 8, Weld Misalignment and Shell Distortion, which is found in API 579.1 or ASME FFS1. And in this presentation, we will refer to the 2007 and 2016 versions. So what are we going to cover? Well, we're going to cover the most basic level 1 assessment, which is the quick assessment for this topic. We're also going to touch on the level 2 assessments, what it all entails, and the level 3 assessments. So let's jump right in. To know about level 1 assessment, it's based upon the original code that the tank was designed and constructed to, or the vessel or the equipment, and to owner specification for fabrication tolerances. And for example, larger clients will have specific requirements for tolerances on the diameter or the fit up of connections. So, for example, ASME Section 8 Divisions 1 and 2, there's a table summarized of their tolerances built right into the code, so you don't have to go back and look at Division 1 and 2. And it's table 8.3, and it's found in both editions. Another example is B31.3. You can refer to a handy table built, again, straight in the code. It's table 8.4. The next one is for low pressure tanks, API 620. Table 8.5 will show you the standard tolerances, and API 650, table 8.6, and API 653, which is tank repair. And again, these are all values taken from these API and ASME standards as a basis for acceptance. So basically how it works is if you're within those owner and specification fabrication tolerances, then you pass a level 1 assessment. It's that simple. So it's one note before we go to the next slide is it's not applicable to cyclical service, a level 1 assessment. Level 2 assessment involves computational procedures for components that are subjected to primary pressure stresses and supplemental loads. And this is where level 2 should be applied. And it includes procedures for re-rating of components, which is not found in level 1. A bit more here. So there's specific procedures about weld misalignment and out of roundness cylindrical shells and pipe elbows. And there you can use combined misalignment out of roundness of the cylindrical or shells subject to internal pressure. And you can use out of roundness shells subject to external pressure as well, which is, considered to be a buckling assessment. Two assessments. There's a for bulges, there's no procedures provided, so that means you need to, for those kind of assessments, you need to do a more detailed level 3 assessment. Look at level 2 assessments here. So we want to be re-rating components, and we can re-rate the component by looking at the remaining strength factor is greater than the allowable remaining strength factor. And if that's the case, then we can pass our level 2 assessment. If we fail, then we should be going back to part 2, where remaining strength factor RSFs are really discussed, and in particular paragraph 2.422 to re-rate on pressure. And note that this requires some iteration. So you have to guess because the equations are not conducible to solving. More thoughts on level 2 assessments. With regards to fatigue analysis, which you're not able to do at a level 1. So this is what it says. It says that there's a screening procedure that you need to follow. In the 2007 edition, you would need to go to Annex B1, paragraph B1 5.2. And if you want to see it in the 2016, then you need to go to Part 14 to go through that screening procedure. And you have to, the nature of the loads, you need to go to Annex A for the 2007. And for the 2016, you need to look at Annex C1. And the approach is the ratio of the induced bending stress to the membrane stress, RB. And basically, the approach is to compute the number of allowed cycles using the stress range. I has some interesting remedies for the case if you have a failing of your assessment. You can consider re-rating the component to a lower pressure and temperature. You can repair or replace. You can, derate the equipment, which I think is pretty much the same, or you can do a more in-depth level 3 assessment. And of course, you can always repair or replace the equipment. Thoughts that API presents when doing a level 3 assessment, and it's a very condensed document, but here's some thoughts on fatigue analysis. So be aware that localized stresses can be reduced if you have an increase in pressure. And that's because it's like when we used to analyze underground piping systems, right? If you have a pipe with very little pressure, then what will happen is it can oval. But if you have a pipe with lots of pressure, then those outwardly expanding stresses will stiffen that pipe and prevent like collapse. So that because they work against the bending stresses. So that's something that you should be aware of. Also, accurate geometry of the component is required. So you have to do a very accurate dimensional assessment in order to produce the results that are accurate. And if there's a kink or a sharp bend exists in a shell, then they consider a process called continuum model with the effects of plasticity recommended, so that you have to know quite a lot about the characteristics of the material that you're using. You should be considering MTRs and going as far as getting bend test type information would certainly be helpful. And of course, at the temperature, the operating temperatures. Comments they make with regards to fatigue and level 3 assessment is that if you've got compressive stresses, then they encourage you to use nonlinear techniques to determine the collapse strength. They also go on to say, in the creep range, nonlinear techniques, you need to understand the creep and plasticity of the material. And there's also be cautious because there's a very high risk of cracking if you're having, materials that are running on the extreme of this range. And also for highly localized stresses, nonlinear techniques and material toughness requirements are to be really thoroughly understood in order to provide this kind of assessment.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.